Hello, and welcome to another video. I know it's been a long time, but I'm so excited to be back. So today we're going to be doing some fraction fun, and this is going to be division and word problems. Of course, with me, Miss Crystal. Well, without further ado, do one favor for me first. Don't forget to like this video, comment if you want to, share it with a friend from your class, but most of all, subscribe. All right, that lets me know that I can keep making videos like this because I have people watching. All right, let's go ahead and jump into it. So this is going to be broken up into 4 days, Monday, Tuesday, Wednesday, and Thursday. And then each day has four problems. So let's start with Monday. All right, here we go. So the very first one, we're talking about baking. So Aiden bakes 5 loaves of bread and shares them equally among 8 neighbors. So how are we going to write this as a division expression? We're going to say it almost like how we say it out loud. 5 divided by 8 neighbors. So that's what we're going to write. 5 divided by 8. What does that look like as a fraction? 5 over 8. And what we're going to be doing is we're also going to be reducing. And if we need to make it into a mixed number, we're definitely doing that. All right, number 2, a farmer has 9 watermelons. He shares equally among 6 workers. So one thing I definitely want you to take note of is this word equally or shares. You might see splits or even divides. Those words let us know we're doing division. When they're giving us something and they want it to be divvied out or divided out into a certain number of people or pitchers or pots or anything like that. So, anyways, we have 9 watermelons and we're putting them equally among the 6 workers. So we say 9 divided by 6, and that's how we say it, that's how we write it, and it would be 9 divided by 6. And that bar that we have here, that fraction bar, remember, that is just a division bar. It looks like a fraction, and it's this big scary thing, but it just means divided by or division. All right. So a lot of times we say 9/6 or 9/6. It's just 9 divided by 6. And that's what's going on here. So this is one of those problems that I said we are going to have to change this into an improper. I'm sorry, this is already an improper fraction. We need to change it to a mixed number. So what do we say to ourselves? We say, how many times does 6 go into 9? And I want you to skip count. 6 times 1 is 6. 6 times 2 is 12. Too big. So we can only go in one time. 1 times 6 is 6. And then we count up 6, 7, 8, 9. That means our remainder that we have is 3. And we're going to keep it over the same denominator, which in this case is 6. Now, if you start really, really looking at those numbers, this is going to become super, super easy. But we have a number at the bottom and a number at the top, and that's half of that number at the bottom, right? So numbers like 4 over 8 or 5 over 10, we know those are halfway over the number at the bottom. And in this case, that 3 is the half mark for the 6. So it's also going to be reduced to a half. So 1 and 1/2. So we put the 1 on top and the 2 on the bottom. And really, what that's saying is we're just dividing by 3. 3 divided by 3, and then 6 divided by 3, and then you get 1 and 1/2. But if that was a little tricky and you're like 9 watermelons divided by 6 workers, and it feels kind of like I still don't understand how did they get 1 and 1/2. Let's take a look. I have some workers here. Aren't they so cute? So here's our 6 workers, 1, 2, 3, 4, 5, 6. And now we're going to give them 1.5 of a watermelon. So here's their 1.5 of a watermelon. So let's group together how many watermelons we have so far. So I have 1, 2, 3, 4, 5, and 6 whole watermelons to start off with. Now let's count those halves. But remember, let's group them together so we know what is 1. So this half and this half make a whole. That's 1. This half and this half make a whole. That's 2. And this half and this half make a whole. And that's 3. So what is 6 plus 3? If you said 9, you're absolutely correct. And that goes to show you how those 9 watermelons get split evenly among those 6 workers. It's so funny because some of them are working really hard and some of them are not. It's so cute. All right, let's keep moving to number 3. All right, number 3 says write the fraction as a division problem. We're going to say it how we actually, we're going to write it how we actually say it. And in this case, 9 divided by 10. That's what we say. That's what we write. 9 divided by 10. All right, moving on to number 4, last one on Monday. It says write the division expression as a fraction. So how do we say this? 8 divided by 7, and we write 8 divided by 7. So with this, we have an improper fraction. Big number on top, little number on the bottom. Let's go ahead and make this into a mixed number. We ask ourselves, how many times does 7 go into 8? 7 times 1 is 7. 7 times 2 is 14. Too big, right? So it's only going to go in one time. But we have a remainder. 7 times 1 is 7. Counting up to 8, it's only 1. So it's 1 with the same denominator, which is 7. So the final answer there is 1 and 1/7 for number 4 on Monday. All right, just like that, it's Tuesday. So we're moving on to Tuesday. Happy Tuesday. All right, here we go. Number 1 says Mia has 11 muffins to share equally among her 4 friends. How many muffins does each friend get? The really, really cool words that we're looking for here, share and equally. Those let us know we're taking that 11 and we're splitting it up into 4 groups. And then in this case, it's 4 friends. So we're doing 11 divided by 4. And we do the same steps that we just did a couple problems ago. How many times does 4 go into 11? 4 times 1, 4. 4 times 2, 8. 4 times 3 is going to be too big. So 8 is going to be as big as we can. It's going to be 12. It's going to be too big. So 8 is going to be as big as we can go. So we're going to have our whole number to be 2. And then let's count from 8, 9, 10, 11. We have our remainder of 3, and then our denominator stays the exact same, which is going to be 4. Okay, so your final answer for this one is 2 and 3/4. All right, let's keep going. Number 2, a gardener picks 15 flowers and places them equally into 6 vases. How many flowers are in each vase? So, what cool word are we looking for? That word equally. We love that word. That lets us know if he's placing them. Oh, that's another word there. Placing them, that means he's separating them into 6 vases equally. All right, so we're going to say 15 is going to be cut up into 6 groups, right? So it's really saying 15 divided by 6. And the way we write that as a fraction is 15 divided by 6. And we do the same thing. We ask ourselves, how many times does 6 go into 15? So let's skip count. 6, 12, 18. 18 is too big. So 12 is as close as we can get. So we're going to say 2 times. And now let's count up from that 12. So we have 12, 13, 14, 15. We have 3 as our remainder, and we have 6 as our denominator because it stays the exact same. So let's see how well we were listening from before. 3 is that halfway mark of 6, which means this reduces down to, if you said 2 and 1/2, you're absolutely correct. So you can start familiarizing yourself with those halfway numbers like 3/6 and 4/8, 5/10, 10/20, 25/50, whatever is one of those halfway numbers is on the top and the whole numbers at the bottom. That's really, really going to be good to just lock in that beautiful noggin. All right, moving on to number 3. All right, it says find 46 divided by 5. Express the quotient as a mixed number. So we know we're going to be changing this to a mixed number. So let's write this out. We have 46 and we're dividing it by 5, which remember, that's the same thing as just a division bar. So we asked ourselves the question, how many times does 5 go into 46? Remember, anything that's divisible by 5 is always going to end in a 5 or a 0. Like if you think 5, 10, 15, 20, 25, 30, 35, 40, it literally ends and interchanges, switches from 0 ending in a 0, ending in a 5, ending in a 0, ending in a 5, so on and so forth. So we know the next closest thing is going to be a 5 that ends in a 5. So we're looking for 45. 5 times what gives me 45? 5 times 9 gives me 45. And then I count up. So from 45 to 46, I'm only left with 1, and my denominator stays the same. So for this one, you should get 9 1/5 for number 3 on Tuesday. All right, let's keep going. Let's go on to number 4. We're almost done with Tuesday and on to Wednesday after this. Find 38 divided by 4. Express the quotient as a mixed number. So we have 38, and we're going to do the same thing, divided by 4, and we draw our arrow. 4 goes into 38 how many times? Let's think. Do we know 4 times 5? 4 times 5 is 20. It's okay to kind of start in the middle to see if you need to go up or down. So 4 times 5 is 20. That's not big enough. I think we can go higher. 4 times 6 is 24. 4 times 7 is 28. 4 times 8 is 32. Oh, we're getting closer. 4 times 9 is going to be 36. That is as close as we're going to get. So we're going to say that it goes in 9 times, and let's see what our remainder is. 36, 37, 38. I counted up to 2, so that means we have a remainder of 2, and we keep the same denominator. Now, I'm pretty sure if you've been using your awesome listening ears, which I know you have been, you already know what I'm about to say next. 2 is that halfway mark of the 4. So in this case, it reduces down to 9 1/2. There we go. Dun, 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 dun. And just like that, we are on to Wednesday. Hello and happy Wednesday. All right, let's look at what number 1 has to say. So we have 3 yards of ribbon that are cut into 4 equal pieces. The equation is 3 divided by 4. So that would be 3 divided by 4. And then each piece is going to be only 3/4 of a yard. I will say it's kind of easy to overthink these problems, but try to just think almost like draw a picture in your head. I will draw a picture any chance that I can because it just kind of helps me out. So look at this picture. Imagine that's 3 yards. You cut up that into 4 equal pieces. 3 out of 4 equal pieces. Again, 3 out of 4 is the same thing as 3 over 4, or 3 divided by 4. So you have 3/4 of each of those pieces being 3/4 of a yard. All right. I love a picture every now and then. It makes it very, very easy to see in my brain. All right. Oh, now I'm getting hungry thinking about pizza. Okay, 7 pizzas are shared equally among 5 families. So we have 7 divided by 5. The way we say it is the way we write it, 7 divided by 5. So we do our little math, our little arrow here. We say, how many times does 5 go into 7? 5 times 1, 5. 5 times 2, too big because that's 10. So we have to stop at 5. So we only went in one time, And now we have to count up to until we get to 7. So 5, 6, 7. And then we have 6, 7. We have 2 as our remainder, and we keep the same denominator, which is 5. There's nothing that goes into 2. There's nothing that goes into 5 that would be the same. So in this case, that's as far down as we can simplify that fraction. Okay, so now let's move on to the next one. Number 3, we have, let me delete this, sorry. Okay, number 3, we have 10 liters of juice are poured equally into 6 bottles. The equation is 10 over or 10 divided by 6, which we would pretty much say the same thing, 10 over 6. Yes. And we write it the same way, 10 over or divided by 6. Now we draw a little arrow. How many times does 6 go into 10? 6 times 1, 6. 6 times 2, too big. So that's going to be 12. So it's too big. So it's only 1. And now let's count up. So 6 to 10. How many will get there? 6, 7, 8, 9, 10. We have a remainder of 4. And that's all over the same denominator, which is 6. All right, so this is not a halfway problem, but this is an even number on top and the bottom. So if it's even on the top and the bottom, guess what we can divide by? 2. We can always divide even numbers by 2, which means we're pretty much chopping it in half. So half of 4 is 2, half of 6 is 3. So our final answer is going to be 1 and 2/3, which what are we actually saying 1 and 2/3 is? The amount of juice that's in each bottle. That's a pretty big bottle, but it's the amount of juice in each bottle. All right, moving on to number 4, and then we only have one more section, which is Thursday after this. You are doing awesome if you're still with me. All right, so we have 12 candy bars that are divided equally. There's our cool words that we're looking for. Divided equally among 8 friends. So that means it's like 8 groups, and we're taking those 12 candy bars and divvying it out into those 8 different groups. All right, which in this case is 8 friends. So we have 12 over 8, which is 12 divided by 8, or 12 over 8. So now we put our little arrow, 8 goes in 12. How many times? Let's count. 8 times 1, 8. 8 times 2, 16. Too big. So we have to stop at the 1. And now we count up. So 8 times 1 is 8, and we're trying to see the distance to 12. So 8, 9, 10, 11, 12. It's 4. And then we have our same denominator, which is 8. I'm pretty sure you know what I'm about to say. But if you don't, take a good look. Look, I'm not even going to say it just yet. Just take a look. If you think we can reduce, you're right. Because this is a halfway problem. This is one of those problems where you have halfway mark on the top and the full number at the bottom, which means this is 1/2. This reduces down to 1 and 1/2 as the final answer. And what are we really saying? We're saying each of those 8 friends, each person leaves with 1 and 1/2 candy bar. So, sounds delicious. All right, moving on. And just like that, guess what today is? Thursday. So pretty. All right, let's go ahead to number 1. Noah makes 9 gallons of lemonade. He pours it equally into 12 pitchers. How many gallons are in each pitcher? Ooh, look at those words, my favorite cool words to look for. Equally, he's pouring it, dividing it equally into 12 pitchers. So again, we have 9 things, in this case, gallons. We need to divvy it out into 12 pitchers or 12 groups. So this is 9 divided by 12. And the way we write that as a fraction is 9 over 12, or 9 divided by 12. All right, we need to think of a number that goes into both 9 and 12. The way that I think about this number that goes into both of those numbers is I say, is there a multiplication problem that equals 9? And is there another multiplication problem that might have the same number that also equals 12? So I think of all my multiplication facts. Okay, 3 times 3 equals 9. Let me start there. Is there 3 times something that equals 12? Yes, 3 times 4. So our number is 3. We can divide the top by 3, which remember, whatever you do to the top, you have to do to the bottom. So we divide the bottom by 3. So 9 divided by 3 gives me 3, and 12 divided by 3 gives me 4. So the final answer for this one is going to be 3/4 gallons. All right. 3/4 gallons. So he has 9 gallons in each of those 12 pictures. 3/4 of 1 gallon is in there. All right, moving on. Let's go to number 2. Number 2 says Ariel pours 15 cups of soup equally into 10 bowls. How many cups are in each bowl? We love those words, equally. It just lets me know we're doing division, right? So that's really saying 15 divided by 10, which is also saying 15 divided by 10. And now it's time for us to do a little bit of changing this number around because this is an improper fraction and we got to make it into a mixed number. So 10 goes into 15 how many times? Let's count. 10 times 1, 10. 10 times 2, too big because 10 times 2 is 20. So that's going to be too big. So we're going to stop at the 1. So 10 times 1 is 10. Let's count up until we get to 15. We're trying to see the distance from 10 to 15. 10, 11, 12, 13, 14, 15. 5 over 10. You probably are a step ahead at this point because we can see that that is a halfway problem, which lets us know it's actually 1/2. 5 is half of 10, right? So it's 1 and 1/2. 1 and 1/2 what? We're talking about cups per bowl. Okay, this is how many cups you're getting in each bowl. And if you don't know, like, wait, what was I solving for? Just look back at the what is or how many question that this usually falls at the end. This one says how many cups are in each bowl. 1/2 cups are in each bowl. That's how we figure out what we're talking about. All right, we only have 2 more problems. You're doing amazing. Let's fly through these last 2 problems. Leo fills 18 buckets of sand equally into 7 wheelbarrows. How many buckets go in each wheelbarrow? So 18 buckets. You got big, big 18 buckets, and we need to put it into 7 wheelbarrows. We're divvying it out. 7 is our group. So it's 18 divided by 7, or 18 divided by 7. Okay. So now it's time for us to turn this into a mixed number because this right here is an improper fraction. Big number on top, small number at the bottom. All right, so we say to ourselves, how many times does 7 go into 18? 7 times 1, 7. 7 times 2, 14. 7 times 3, too big, 21. So we can go all the way to 2 this time. Now let's count what our remainder is. So 7 times 2 is 14. And we're trying to see the distance to 18. So we start 14, 15, 16, 17, 18. And we have 4 as our remainder over the same denominator, which is 7. So we have 2 and 4/7. And also, just so you know, there's nothing that goes into 4 and 7 that's going to be the same number. So this is as far as we're going. And what are we talking about? Buckets go in each wheelbarrow, 2 and 4/7 buckets per wheelbarrow, per each wheelbarrow or per one wheelbarrow. All right, we're on the last problem. You're doing amazing. I'm so proud of you. All right, a class collects 20 pumpkins for a fall festival. They are placed equally into six groups for different games. How many pumpkins are in each group? I love these words. Place and equally. That's like telling us we're doing division, right? And then I love how we finally have a groups. Usually we have like six friends or six vases or, whatever. But now it's actually groups. That's like letting us know these are the big buckets or these are the big groups. And we're divvying out these 20 pumpkins evenly. So it's 20 divided by the six groups. Or to rewrite that like a fraction, 20 divided by the six groups. So now we say to ourselves, this is an improper fraction, and we've got to turn it into a mixed number. So in this case, how many times does 6 go into 20? 6 times 1, 6. 6 times 2, 12. 6 times 3, 18. 6 times 4, too big. So 6 times 3 is as far as we can go because 24 is going to be over. So we're going to start with our 3 or stop with our 3, I guess. And now it's time to see the distance between 18 and 20. So we say 18, 19, 20, and we're left with 2 as our remainder and 6 as our denominator. Now, here's the thing. This isn't a halfway problem, but they're both even numbers. 2 is even, 6 is even. So we know we can divide by 2 or just cut it in half. What's half of 2? 1. What's half of 6? 3. So the final answer here is 3 and 1/3. 3 and 1/3 what? Read the last part of your question. Pumpkins are in each group. So 3 and 1/3 pumpkins per group or in each group. You did phenomenal. When I tell you, round of applause for all of your great work. And thank you so much for hanging in here with me this entire time. I'm super proud of you. Remember, leave a comment if you want me to do your homework next. I cannot wait to see who sends me their homework next so we can do it together. Thanks for joining me.